Welcome to the School of Logistics, the podcast where logistics, technology, and geopolitics overlap. Today, we're diving into a world first development that's transforming inland navigation, the launch of Flanders' first remote control center for locks and bridges. This groundbreaking project, unveiled in September 2024 in Hasselt, marks a major leap forward in automation and operational efficiency for inland shipping. For the first time, a central control room can remotely manage locks and bridges, revolutionizing how vessels move through Flanders waterways. Flemish Minister of Mobility, Annie de Ridder, called it a pioneering achievement, and for good reason. The impact is massive. Shippers can now operate 24/7, putting inland shipping on par with road transport in terms of availability and efficiency. This isn't just a technical upgrade, it's a complete reshaping of maritime logistics. Training programs at Awatar are already preparing for the next generation of traffic controllers. And by 2032, all 427 movable water structures in Flanders will be remotely operated. With 3.2 billion euros in infrastructure investments and a private fiber optic network, Flanders is positioning itself as a global leader in smart waterway management, attracting attention from international delegations looking to study and replicate this model. But what does this mean for the future of inland shipping? How does automation impact logistics operation? And what challenges remain despite these advancements? Buckle up. This is School of Logistics with DocFlow's founders Pauline van Osteyen and Michiel Valee. Michiel, Pauline, welcome. How are you?
Thank you. Doing good.
Perfect. Well, first of all, Michiel, congratulations on your birthday.
Thanks so much.
Did you do anything fun this week?
Well, I had fries and I had pizza on the very same day, so I felt like I was 12 again.
And the team gave you a very personalized
Yeah.
present, right? A survival kit.
Survival kit with all my snacks that I drink and eat during the day.
Let's not go over those snacks because we don't know what's in there. Well, but then let's dive into our first problem. The first remote control center in Hasselt is a world first, but inland navigation has historically been slower to adopt automation compared to ports and trucking. What were the key technical and operational challenges in implementing remote controlled locks and bridges, and how were they overcome?
So yeah, there are a couple of technical challenges that we saw, and on an operational level as well. So of course, technically, there's the infrastructure question because you really need this to be very reliable and seamless, right? You can't have suddenly a lock becoming uncontrollable. So you really need a reliable connectivity. And Flanders addressed this by really building a secure, dedicated fiber optic network that connects the lock and the bridge to the control center.
Yeah, I wonder actually why they did that. Because I would rather think of having multiple layers of network connectivity, because the private fiber seems like an expensive option to do, but they must have had a good analysis on it.
Yeah, that actually is kind of links to another operational challenge, which is safety and redundancy, where of course, because safety is involved, you really can't compromise on that. So they added multiple layers of redundancy. You need backup systems and overrides to at both the control center and on site as well. So yeah, I don't know whether they did that on the networking side, but that's definitely an operational challenge to build in the redundancy.
The same.
Yeah, it's for sure a major milestone with plans to expand remote operations to all 427 movable water structures in Flanders by 2033. From an operational standpoint, what are the immediate efficiency gains of centralized control, and how will this impact vessel scheduling and congestion at key locks and waterways?
I believe this was one of the main drivers for them to proceed with the initiative, because by having this remotely managed and maybe even automated to some degree, you can actually extend the operating hours as well. So you can have really 24/7 operation. With maybe a side note, I live next to a bridge that is moved by the Flanders waterways, and that's there's a road on the bridge, and sometimes the bridge will open at very busy times when there's a lot of traffic jam. So of course, if you can have operation of it at night, then that is perfect. Then you'll increase throughput tremendously and also lower the
Absolutely. It's one of the chains that needs to be open to operate at 24/7. But of course, all the locks need to be open at 24/7 then, and you need also warehouses to be open 24/7, because if the cargo cannot be unloaded or there is no terminal that's open. So it's one of the key elements that we need to have to operate more efficiently.
Yeah, the being open 24/7, I think it's a very difficult discussion in Belgium. We see in other countries there is, well, more, they have more freedom to do what they want in terms of that. Do you think Belgium will go forward with everything being open 24/7? And how will people manage to keep working around the clock?
I think what Michiel mentioned with the connectivity with warehouses or even other modes of transport. For example, if you have let's say it's a container on a ship and it's moving on to a train or maybe a truck, then that also has to operate 24/7. Also in terms of infrastructure, not possible. And the infrastructure is old as well. If I look at that bridge close to my apartment, I
It's a
think
very slow one, I know.
it's it's extremely slow. But did you know it's more than 100 years old? And it's protected as, how do we say it? Erfgoed. So it's protected as a monument, let's say.
Oh, really?
Which means that they can't just swap it out for a more modern version.
That
But
reminds
it's
me of the
also,
escalators going down by foot to
I
the
think
other
it
side
was,
of
it's from
Antwerp.
the same kind of
Yeah.
period, I assume. So yeah, if you've got a lock has engines that are 100 years old,
It's
then
not easy to
automating
connect
them, I
those.
mean, it's a little bit of a contradiction.
But I think generally, and also politically, people know that we will be going towards these 24/7 operations. Everybody would like that the roads are more free during the day. So of course, we need to make sure that the framework laws, everything is there, and also technology.
And that also should be harmonized across different countries, because if it's happening in Belgium, then it has to be adopted. Yeah, this has to be standardized even on a European level, probably.
Yeah, definitely. You said that the bridge is over 100 years old and there's a lot of investments going on. But despite these infrastructure investments, growth in inland shipping remains very slow. What logistical or regulatory bottlenecks still hinder inland waterway transport, and how can automation overcome these problems?
For what I know, it's a combination of cost and just not knowing the mode of transport. So it's very easy. Everybody who does a transport can order a truck and everybody knows how that will go and how it works. But for inland shipping and rail and other modes of transport, there seems to be more planning required. Even if it's not true, but in people's mind, there seems to be more planning required. So it's higher the bar for actually doing that.
Yeah. I also think in Belgium specifically, if we were to implement 24/7 operations in the port, for example, it's already so difficult to find staffing for regular hours. So how are you even going to find double the amount of people to do it at night? I think that really will depend on automation.
Yeah,
Definitely. Well, automation will bring us to the next key challenge as well, which is sustainability in logistics. As inland shipping moves toward automation, the next step is tackling the carbon footprint. And one of these breakthrough making waves in industrial decarbonation is Germany's largest hydrogen electrolyzer at BHSF Ludwigshafen site. This 54 megawatt facility produces over a ton of CO2-free hydrogen per hour using proton exchange membrane electrolysis, a clean alternative to traditional fossil-based hydrogen production. Powered by renewable energy, it's a major step in BHSF push for greener industrial processes in Germany's hydrogen economy. Given the challenges of hydrogen storage and distribution, how feasible is it for logistics companies to integrate hydrogen into large-scale transport operation, particularly in inland shipping and trucking? Or is it too early to talk about such scale adoptions, you think?
I think there's two things there. I recently had a discussion about decarbonization in inland shipping, where already like newer alternatives are available, because also battery powered vessels are available there. It's much more feasible to do it inland than it is in ocean vessels. So they are available, but also biofuels and so on, which requires an investment, but it's less carbon. However, the main thing there is still to make sure that the vessel is full. If you sail with a full vessel full of containers and you can get a full cargo load back from the other location as well, then it doesn't matter too much which kind of fuel you're on, versus the biofuel where you only have 3 containers maybe on your vessel where you could have had 10, or you sail back empty. So of course these fuels are important and are one puzzle of the piece, but not the full thing yet.
Yeah, there are a lot of gains that can be made before even getting into big high-tech solutions. When we were preparing for the podcast, I kind of took myself back to the high school chemistry course and refreshed on how hydrogen is actually made, which is through electrolysis. Which if you've had chemistry in high school, then you've definitely done electrolysis experiment where you then created some hydrogen which you could light up with a flame, of course. But I think one of the fundamental questions with hydrogen is also with using hydrogen as a sustainable fuel is the fact that you're taking electricity and you're using electricity to make hydrogen, because that's the electrolysis part where you have water and then you create hydrogen with electricity from that. And then in your vehicle, for example, in your car, you're actually using that, converting it back into electricity, and you just lose a lot in those steps. Like it's not a very efficient way of using the resources. So you've got a big it's actually got a name as well. It's called the hydrogen efficiency penalty. So basically it says that producing hydrogen from electricity, and when you store or transport it and then convert it back into electricity, you'll actually get substantial energy losses. So it's a lot less efficient than using direct electricity, for example, batteries in trucks. But actually the technology that BASF is using makes it the electrolysis process a lot more efficient with their proton exchange membrane. So that's a great, I think, great progress for improving the electrolysis process, and that really makes it truly more green than hydrogen previously is. Because right now you see that it's rolled out whenever there's big subsidies or like government regulations or initiatives, because the incentive is not that efficient actually to use yet.
Definitely. Well, if we look ahead, do you think this business model of BHSF with their hydrogen powered solution will be sustainable for the long term into the hydrogen economy, or is it just a hype or a new finding that they now have, and will it just die out in the long term?
I definitely wouldn't say it's a hype. I think it's definitely one of the key components towards alternative fuels. And we will need, for different kind of applications, we will probably have different kind of fuels. It's hard to store hydrogen in large amounts in difficult circumstances. However, there are also some occasions where you can store small amounts, or you can refuel and you can have them in smaller amounts, where it's a very feasible fuel, I think.
I think they specifically also combined it with long-term energy or renewable energy agreements, which then helps them, of course, hedge their risk a little bit as well, to not be subject so much to price fluctuations or anything big happening in the market.
Perfect. Thank you very much for your insights on these topics. Is there anything interesting that happened this week that you would still like to touch upon?
Not right now.
No, perfect. Then I thank you very much for being here, and we'll see you next week.
Thanks for having us.
Thanks, Michiel.